So maybe first an introduction. The OnChainBunnies. It's actually the result of my thesis. So I'm a last year computer science student at KU Leuven, and I'm writing my thesis. Actually, it's done now. And for this, I'm looking into ways to store NFT collections on the Ethereum blockchain. I created my own collection, OnChainBunnies, together with my little niece. She drew all of them, and I implemented it. And I tested everything I found in my paper on this collection. So all the optimizations, the best optimization and combined are put into this collection. And I wrote a white paper that combines all the best techniques. And the first one is the loot algorithm. So you can store your traits separately instead of the whole image. I think I reduced my collection there with a factor of 800. So it's a big, big, big reduction. It's quite complicated to implement, but I described it in my paper.
I wanted to introduce for a second about what actually on-chain means. This is an important
On-chain,
concept.
Yeah, good question.
This touches on a few topics. One of them is what happens if my NFT pictures are disappeared. The other one is what if IPFS is slow. The NFT lives on the blockchain, but the picture is pointed by a URL somewhere else. The picture is just on a website. But here the picture is not on a website. The picture is inside the blockchain. It can't be turned off. The website can't be removed.
Have you compared exactly like if you stored the pixels on chain versus just storing the code for an SVG file? Like what is the actual difference?
Yeah, here's your answer, Dan. It goes from 2 kilobytes to 100 kilobytes.
The second one, optimization, is the optimizer. Now, someone invented the optimizer. So what does it do? It's an optimizer that does the translation from Solidity to these opcodes. And you can make this translation as efficient as possible. Just do it. It gives a lot of advantages. Then if we go to the third technique, here there are some contradictions. People are saying, I call it memory data, but not everyone calls it memory data. Most of the NFTs, if you store them on-chain, they are stored in storage data. So you use it in a method, you declare it inside a method, and every time you ask for the image, this method is declared again. So it reads the code, it gets declared, and it gets deleted. But the code stays there, so every time again it gets declared. But in this way, we don't use the state variables, which makes it way cheaper. So this gives an optimization percentage of 44.32%. William, I will need an image from the white paper for this. Yeah, that's it. So the last thing is, how do we store the IDs of our bunnies? Because we can extract all the traits from these IDs. We will use bits for every trait. For example, if we take a look at the bracelets, so there are 6 different bracelets. And then what we will do is we mix all the bits. So this means that we extracted tie ID number 9. And we will use this for every single trait. So in this way, we can extract all the traits separately, just with bit field operations, which are really cheap. I don't know if you understand that.
Yep, so we've got the naive way. I guess you always have to explain it from the naive way too. Is the naive way is you just put them in order.
It was kind of difficult to implement indeed, because it's not always representable with these bits. We have IDs that don't exist, but we use the checker for that. So it is possible to implement even if you don't have these 2 to the power of X amount of features. But yeah, it gives a big advantage because you can store all the features in just one integer, which indeed saves you a lot of gas. So these were the biggest gas-saving techniques I used. But while I was implementing this, I came up to another thing, and that is insider trading in NFTs. We saw some examples. There was an article in Forbes like 1 year ago of a big rich guy who got caught. You always have these reveals in collections. So you have different kind of reveals. For example, you can buy an NFT, mint an NFT for the first time, and then you have the possibility maybe that it shows the art immediately, but you don't know if you mint it, which one it will result to. And sometimes you also have these phases where it's just everyone has the same image, and at one moment they all get revealed. And mostly in these phases there is insider trading, because the developer knows which ID will result in rare trades. And if the developer tells friends and family, those friends and family will pay a lot more than the floor price for these IDs. However, they're exactly the same as all the others. And that's how they got caught. So how do we implement this if we have on-chain NFTs? This is something not that easy to implement, because we need to reveal them randomly, that also the developer doesn't know which IDs will result. The most well-known methods are using block information. For example, before the merge, we had the block difficulty, or you can use the timestamp, or you can use the miner address, the validator address. Now we also have something as pre-Brandao, the field that says who will be the next validator, together to generate the random number. But then it's not done. So you have the random number. What if 2 times the same random number gets picked? Then you have 2 times the same NFT, and to detect which one are already minted, you have to store all of them, and you have to loop over them, and that is something expensive. So we don't want to do this. So we want an algorithm that picks the NFTs randomly without picking one twice. And that's what we implemented here. So the basic idea behind the algorithm is that we will pick IDs in an ascending order. And by picking them in an ascending order, we make sure that not any ID will be picked twice. And every ID will result in a different combination of traits that's unique. And that's what we implemented with the bit field encoding.
I got a question.
Yes.
Why would you want to get rid of insider trading? Because for me, that's my favorite part of what you created.
I think, I know what you mean, but if we want to get NFTs to the broader public, we have to get rid of this bad image, right? This comes into the newspapers, it's not a good thing.
No, for sure. I just wanted to see. I wanted to see him light up on camera. But good, no. Obviously, it's a problem, and we even have some kind of I forget. So when projects would reveal, the placeholder image would sit there longer for others while it would, the metadata was refreshing, and we would go through and be able to pull up like the PHP file that had the traits.
Yeah, exactly.
All you have to do is replace, the last part of the URL. You just change we would go through and snipe the rares and whatnot. So doing this removes that PHP file from existing.
That's why we decided not to use this phase, but we reveal immediately at mint. So you pick the NFT, you mint it, and you immediately get the image.
Okay, excellent. So that's how you sidestep,
Yeah, that's the best way, actually.
There's trade-offs here. So this approach, one of the trade-offs is that you can always abort a transaction. So what you could do is you could mint it, but then if you don't get the traits that you want, because they're revealed immediately, if you don't get that trait, then you just don't put that transaction in. And
exactly.
This is something you can do, but you require MEV miners to do that. So you have to use the backdoor.
Yeah, exactly. And also the thing is, you can only do it at the end, because if you do it at the beginning, you don't know which traits will be picked later on, so you don't know which rare ones will be picked anyway.
I see. So you sandwich your own transaction if you don't like it.
You sandwich yourself.
You should have just said that. That was
Now, I'm not saying this is wrong. This is an approach. But you just need to understand the trade-offs with randomness and with blockchains.
Yeah, definitely. Yeah, there are different ways to implement the randomness. And I think you have to look into the smart contract to see how they did it. Some ways are good some ways are nice to implement it and not that predictable. Some ways the validator or the miner can just cancel it and then it's not random.
Like, could they make it harder for you to mislead you?
Absolutely.
And another point I was going to say, it really doesn't matter if it's a hype project and everyone's buying it, because by that point, by the time you go to read the code, it's sold out, and you got a sold out sign on your screen, and all your friends are like "LOL," and there are 4xing on some code that doesn't matter
There's
anyway.
a couple things too. Is when you do these projects, like a real project, you have a beta test, and you got to be open about this stuff. That avoids the like, oh, I'm opening the page and it's already sold out, and I don't even know what it is yet. Like, you want to know what these things are before you start buying them.
Yeah. Well, those days, I hate to inform you, the thing that you created started those days, and so that's your fault. Second of all, it makes sense. Like, big company. If you go, all right, so it sells out. People can go back and look at the code, and if it's not this randomized, then you can start a FUD train and bring that project to zero, and really damage it anyway. Because now you can sort of prove that people were playing favorites and sending.
Yeah, and that really hurts.
Can we look at the Bored Ape contract? Can you tell me how random that was, just for giggles?
The Bored Apes are off chain, so it's difficult to say. So they did the algorithm off chain, so we cannot see the code on how they did it.
Interesting.
So that means there's trust involved.
Yeah, you trust the developers that they did it. They do the randomize, and then they see, okay, there are duplicates. Let's do it again, until you don't have any duplicates. Not really, because you do it multiple times.
Yeah.
Until you find a good score.
Yeah, you kind of, it's just, that's, I think Pete Rose went to jail for that. No, that's just a baseball joke. So what would be a good example of a project that has this, this level of randomization?
Really, on Mint, I think the on-chain birds did a nice thing, but they were not able to detect the duplicates. So what did they do? They set an off-chain server that detected the duplicates. Once they saw a duplicate, they burned it and they minted again.
Interesting.
But pure randomization at Mint on-chain, that's the only project I've seen. But yeah, just my opinion. I don't know. Maybe there are some.
Yeah, I've got an article here that studies a lot of the randomness of the different drops. So this goes just specifically into the randomness part. This is linked in the show notes.
I love watching his delayed smiles come all the way from China. It's actually kind of a treat.
Yeah, so welcome to the party. Thanks for joining.
I'm excited to be at the party.
For people who don't know Rob is working on Remix. Remix is everybody's favorite IDE. This is some great software that back in the day you would use just for playing around with your smart contracts. But now it does a lot more. It does testing. I recommend people to use it for even deployments. It's a great tool for deploying stuff and trying it. You can do teamwork on this stuff too. Maybe you could tell us a little bit about yourself and how you got into the project.
I got into the project by taking a class many decades ago. It was called Telecommunications for Artists. Someone from that class was in Ethereum Foundation, and so then I got involved in this project.
So what's your scope on the project?
I'm mostly like writing documentation. I'm writing the Learneth tutorials. I'm giving presentations. I'm the person to complain about for when the documentation doesn't work. I'm doing a lot of community outreach, a lot of UI, figuring out what's the right UI for the project.
Yeah, I appreciate that. And to be honest, I didn't know there was any documentation on this until we started talking.
If you go to like the Solidity compiler, just to the right, there's that green check mark. And if you dial down the caret, you'll see a link to the documentation for the Solidity compiler. And that's true with all the side panel plugins.
I've been using this for years and years. Never saw this button.
For learning Solidity and Remix and a lot of other issues, you can go to the Learneth tutorials.
On the right side of the homepage?
Off the homepage or off the plugin manager.
one of the plugins that you have to turn on?
Yeah. But you can also just do it off the homepage. If you go to the Learn section and go to Intro to Solidity.
Get started. And it jumps over. Hidden right under my nose.
Yeah, and there's a whole bunch of tutorials in there. You can do static analysis with Slither and with Solhint linting right in the static analysis plugin. Actually, that's coming out in the release, which is in a few days. So maybe I'm jumping the gun a little bit. So it's teasers of what's to come.
So what have you learned about people that are using this stuff?
There's people at all levels using Remix. There's, of course, everyone assumes that it's just for beginners, and because it's just a very easy place to start. And then people are also, advanced devs who have many reasons for using Remix. Some have a computer at home and at work, and they just want to have their development happening in the same place online. And so they use that. Kind of like advanced devs or even people that are just kind of managing projects are using Remix just to check the health of contracts.
I use it because, okay, I'm a founder, I'm a money person, I'm an idea person, and now I have to go deploy a smart contract onto that's so far beyond what they signed up for. So then you're like, okay, install software, open terminal, don't spell anything wrong because spaces matter and uppercase counts, and there's no undo button. That's the world you're dragging like founders and CEOs into. With Remix, you just say, okay, take this folder in this email, drop it into here, and click this button, and you give them a screenshot.
And you can also clone a repo. You can also give them a gist. You can send them a URL that has a gist, that loads a gist.
There's just something about clicking buttons that makes it more friendly for people that don't do computer stuff, and it makes them less scared. And there's a test net, and it's right there. And you don't have to be like, okay, see that file that says configuration? We want you to edit that, change it from test net to production. Like, you're so far over people's heads, and especially the type of people that should be deploying this stuff. And some of the laws that are coming, actually, in Europe, if you deploy the smart contract, you will have liability.
Yeah, you are the only one that we've heard from who has the clients deploy. But I've been pushing that as well. And when people hear that, the light bulbs go off. Like, oh yeah.
Yeah, let me refer you to the past 3 episodes where we've reviewed the new laws that are coming in Europe called MiCA. And actually, there's laws against there's liability coming for developers that deploy.
Oh, and the other thing you should know about Remix is that right now you can see it in Chinese, and then go all the way down.
Yes.
It's soon coming to more languages than just English and simplified Chinese.
French?
And actually, there's going to be a French, Spanish is coming. Learner tutorials are already in Chinese and Spanish.
Maybe I do have a question.
Yeah?
Is it possible to interact with smart contracts that are already deployed?
Yes, if you go to the deploy and run panel, and you go to add address, you just need the either the ABI or the source code.
The whole point of interfaces is you don't need to know how it works. You don't need the code for the contract. If it's an NFT, you can access it the same.
Yeah. And then once you get it, you get the deployed contract just below where it says deployed contracts, and you can interact with all the functions there. Also now in Remix, you've seen the templates to have an NFT template. Go up to workspaces, click the button there, choose the 21 there.
Yep.
And then you can...
and you can drop the features right in.
Yeah. And with UUPS upgraded contracts.
This is great stuff. I mean, this is exactly what you need.
Also, there's a whole Git integration. So you can do the push and pull there. And it's basically just like it's kind of modeled on VS Code's Git panel.
I've definitely been in classes where the Remix website will not load. That actually happens.
Oh, that's something else coming too. We're working on making it work low internet areas. The desktop version will probably load with a bunch of compilers already there. And so it will, ease the problem of bad internet.
And you can have people download it ahead of time.
Yeah.
Very cool.
And also another well, there are a few funny tricks of getting validated contracts into Remix. One is if you go to Etherscan to a validated contract, and you just swap out the Etherscan URL for the Remix.
Yeah.
Oh, then I'm going to give a plug for getting people to sign up to be beta testers in Remix. Sign up on the Home tab, and if you do, we have a badge program. We get an NFT badge. It's not transferable, but you get to mint a friend badge.
Yeah, let's get
You
that
lost
link.
me at mint. I was bullish until you started talking about NFTs. Like, I was almost there.